Okay, so for part 8 of my CPT, we begin with research. The image above shows the roller coaster Behemoth at Canada's Wonderland, which is in Vaughan, Ontario. This roller coaster is 70 meters high, has a drop of 69 meters, and a track length of 1,620 meters. It can travel up to 125 kilometers an hour and takes around 3 minutes to complete a ride without any upside down position. So, it essentially relies on basic concepts of physics like gravity and energy conservation. Its maximum gravitational potential energy is reached at the top of the first hill, which is determined by the mass of the roller coaster and the hill's elevation, and also the acceleration brought on by gravity. We can also connect this roller coaster to topics we learned in grade 12 advanced functions. So this roller coaster actually connects to polynomial or sine functions and can be used to represent the coaster's height as a function of time, and quadratic relationships are needed to understand how potential energy is converted into kinetic energy. And then throughout the course, I was able to create my own roller coaster based on the knowledge I've learned. Starting at the beginning of my function, we have an exponential, which is there in blue. The purple acts as a quadratic or a polynomial, and then we move to the black, which is a sine cosine, and then the red is also a sine cosine. These next three are sine cosines, and then the purple lines that you see are just manipulated log functions, and then that one little red there is another polynomial function. And I was just able to manipulate each of these functions to give me what kind of area I wanted them to act as in my roller coaster. And then over here, I just have all of my functions in a piecewise with their restrictions. I did use ChatGPT to create this piecewise. Just for display purposes, I did not use ChatGPT at all in this. I just thought it would be easier and more neater for the viewers to understand what each of my functions were, along with their restrictions.
And then just a brief summary, let's go for a ride on the Tanvi's Wrath roller coaster, which is 350 seconds long. The roller coaster begins at 0 feet above ground, and after 110 seconds, we will reach the maximum height of 225 feet. Therefore, the values for the domain of this roller coaster is x, the value of all real numbers, and the range is y must be greater than or equal to 0. We will be moving slow during the intervals of 0 to 39.8 on the x, because we will be going uphill, which means that these are the intervals of decrease. We will be moving very fast during the intervals of 106 to 116 on the x, because we will be going downhill, which means that these are intervals of increase. In function notation, at f of 12, this would equal 12, which means at 12 seconds the roller coaster is 10.4 feet above the ground. After 24 seconds have passed, we will be at 23.5 feet above ground.
And then the following is just a function attribute chart with everything on it. Following this, I calculated the rate of change at 4 different points. At the steepest, the point where the roller coaster increases, where it decreases, and at the local maximum. I just used the slope formula for this.
And then using algebraic calculations, I found one point in time where the roller coaster's height was above 200 feet, and I determined that at the given function, at 45.225 seconds, the interval would be above 200 feet.